Well, hello, and thank you for that amazing introduction, Aline. I've cherished the last 20 years or so since we started out in this industry as fresh young sales reps so many years ago, and it has been an absolute honor and pleasure to watch you grow and to watch you become so successful. I would also like to thank the distinguished guests as well as the staff from EPG for putting this platform together, something that is very valuable to those who would like to spend more time learning about new technologies, emerging technologies, and other areas within their own space. This will be somewhat of a quick overview. I decided for time's sake to remove all of the individual appearances and removals and flashes of items, and I'm just going to go through and show the entire slide and walk through it. And it's going to be conducted in a storybook type of format. And what I mean by that is I will take some of the successes that we've had in other type areas and then relate that back into how it may affect or impact this space in gas, oil, wind, and other types of energy. So this is the agenda for the day. We're going to first go over the 2D global overview. Then we'll talk about a quick introduction to nano and two-dimensional materials, the transference of those emerging technologies into gas and oil, the 2D material availability and how 2D materials are available within the space, specific applications and how those translate into your everyday interactions. And of course, the reduction of carbon footprint, which is really the task that we have at hand at 2D Global for moving a lot of these products forward into various industry platforms. And then, of course, our close. So very quickly, our tagline is representing tomorrow's technologies today. 2D Global is a nano and 2D materials company. I love this quote from Sully Sullenberger in one of his lectures that in the pursuit for emerging innovations, we must be scientifically literate. And if you'd like, you may see in some of these slides when you go back and they're sent to you separately, or you have the opportunity to download these, there are specific links on these slides that lead you into deeper dive videos which relate to the slide and the topic that's being discussed on that slide. And then, of course, my name is Patrick, and I am with 2D Global. My email and my cell phone information is listed. We are a very diverse company. We work in over 50 different platform application industries. As you can see, there ranges from biomedical to nanotech to biosciences, filtration, biology. We work with NASA. We work with the new COVID-19 support and antibody testing and biocides, sanitizers, disinfectants, and all types of things. We have approximately 1,100, so 1,176 registered clients who all expect speed and efficiency from us, which help increase their profit. And then we are a cage code registered SAM business, which means we interact with the government agencies, most of all the 3 and 4 letter agencies that you may be familiar with. We are a veteran owned service business. And of course, we consider ourselves, and many others as well, to be the leader in disruptive emerging advanced technology. When you try to step back and wonder about the impact that you've made, and you kind of gauge and take inventory of your message, you wonder how far that's reaching. This is just a fun cartoon that was published about a year ago in one of the London business journals in the UK. I thought it was pretty funny. It actually lists my picture there, and the detail of the cartoon is pretty amazing. I have a tendency to wear my sunglasses on the top of my head there. I'm not sure that I look like that any longer. Maybe 20 years ago, I would have had a shot at that. I think you kind of reverse the kind of turn it upside down, if you will, and that's more representative. But it's a fun illustration about graphene and what graphene does, and it compares it to steel there in as Superman. You can go to our website at 2dglobal.com and see most of this information. These are our NAICS codes, which really specify on the areas that we dive down into and put into certain verticals. We do have a registered government mandate. We are registered in Dun and Bradstreet, and we are undergoing an upgrade there as well, which is very exciting. And then, of course, it lists some of the other areas that we're involved with, including HIPAA and HIMSS and TDI and the Department of Logistics Agency and different things like that. So let's get into the meat of it. The future is made of nanomaterials. By creating partnerships with people like EPG and your companies and innovative companies and institutions, 2D Global is helping to create the next generation of various platforms, including composite materials, fluids, friction agents, quantum dot tracking, and other type applications that may not be familiar to you. Approximately 90% of our revenue is generated on an annual basis from product development that the general public will not be aware of or will not see or will not be introduced within the next 5 to 7 years. So it's a very exciting place to be. So what is graphene? We've heard about this graphene, two-dimensional material out of all the two-dimensional materials. You often hear it called the wonder material. And you can see one of our reactors there with the staff working. Graphene comes from graphite. It's actually, in the structure, one atom removed from it in the molecular structure. It's one atom thick. It's interesting. It conducts electricity better than silver and copper. It conducts heat better than diamond. It is stronger than steel. It's extremely lightweight. And as I mentioned, it's only one electron bond removed from that of diamond, facilitating the orientation and the use of that free electron to create varied matrices, which allows us to do some very interesting things as we blend those in as an additive to our formulations in various platforms. Down at the bottom, I do have another link. It's called the 2D Global LLC. The SciShow, we're a sponsor of that. And it's approximately a 7 to 8 minute overview of graphene as a material, the development of graphene, the discovery, where it fits, and maybe some challenges and pitfalls to the future development. So how does this apply to you here at EPG? So graphene, as it states there in its purest derivative form, has been a topic for many, many, many years. However, the application into the gas and oil industry has only been popularized here in the last few years. In fact, I've been part of a movement that's really educating different areas and educating companies and being asked to come in and discuss about the evolution of graphene and how it can fit into different platforms of application. Due to its unique chemical structure, electrical and mechanical properties, and so on we've discussed, here are just a few of the areas that it may apply for you. Now, this is a limited number. This doesn't cover all of them, but it does cover quite a few, and it covers some that have been pioneered recently with some strong application advancements and some testing that has offered some very positive impact results, and that would be in drilling. An example of that might be in the fluid, it could be in the mud. There are a number of areas that it could be used in drilling. I have an illustration coming up that talks about the in-pipe, kind of a Peltier system, which helps direct and remove heat either to or from someplace within the drilling process, especially if you're looking at horizontal drilling and you're moving through different types of angles and heat's building up and you want that heat pulled away. Graphene can be a great conductor to pull that in a singular direction. Lubrication, this is very strong in the automotive industry and oils, for your industry, greases, and different types of lubrications. It's used across the board in a number of different areas. Desalinization. Filtration, I have an illustration coming up where filtration is a big area here. So one of the interesting topics that is discussed quite often, and I come into companies to help, is you have these filtration systems and the end caps from the epoxies or the polymers or the different types of adhesive agents are starting to degrade quicker than they had before, since the systems are now operating at both temperatures and speeds, along with the combination of pressure that are higher than maybe 2 years ago or 3 years ago, where you could get years worth of wear and tear and use out of these filtration systems. They're now breaking down within weeks or months. And we've been able to go in with graphene as an additive, kind of manipulate whatever that structure is within the adhesive product or the polymer in some of these, and I'll show some of that here in a future slide. And we've actually achieved levels that have not otherwise been thought achievable. So you're achieving pressure levels, you're achieving temperature levels, you're getting to the usage point of being able to maximize the benefit of your equipment, and that doesn't become the weak link. Anti-corrosion coatings. Number of different applications here with anti-corrosion. Because of the properties within graphene, we've seen salt spray hours increase by 5, 6, 7, almost 10 times in some cases, and we can offer deeper information into that area as well. Cementing, this is big, right? This is a huge topic over the last 7 to 10 years based on some of the failures, some of the catastrophic events, things that have happened across the board globally. And so what you look at is getting that matrix within the cementing to be stronger, lightweight, but stronger, and at the same time be somewhat flexible to the changes in pressure and weight and things like that. So there's some very good studies occurring there. Graphene is being used within the cementitious market space quite frequently, and it's really being targeted towards high value, high stress, higher performance type areas at this point. But we have gotten down into things that move towards grouting and different types of panels, some tiles that are being made because of its ability to reduce vibration, its ability to spread out temperature, things of that nature. Oil water separation, again, this kind of walks hand in hand with filtration, but as you know, is kind of at a different level and requires some unique steps, and graphene can play a big part in that. Spill cleanup and mitigation, this is huge. I have a slide that discusses this somewhat in greater detail. And again, this really is about the super absorbent polymer manipulation that the graphene can get in, and it actually can assist in spill cleanup, absorption, and then mitigation afterwards when you look at the disposal process through the neutralization of unique materials that may be within your spill. Emulsion, stabilization, pig tracking and replacement. This is really based on the quantum dot tracking, inline tracking, where you can actually program some of these graphene molecules and watch those through some form of monitoring in a computer or a handheld device situation to give you feedback on that tracking. These molecules can be arranged in a structure that can actually be programmed and monitored to offer you different types of feedback based on various dynamics and inputs, outputs, and influences, and then many other applications as well. So here, this is a busy slide, and I apologize, but this kind of shows you if you start at the top left and go through, then move up to the top right and look, and then kind of in the center. So you see some headphones there, some thread, the oil well with the drilling, the ballistics, the AI. Down in that bottom left hand is a picture of a degraded filter. I will show you a filter end cap. I will show you what the filter end cap looks like of the same time and space, pressure and conditions with the use of graphene. You can see at the top, you have the coating that is applied, and we have a separate slide for that as well. Very exciting that it can be used to replace heat tapes in areas where you need to monitor temperature. It's actually can be included in a paint or coating that goes on. A small electrical charge is applied to it, and you can increase or decrease the temperature that you need at that point. And then, of course, you see corrosion control and different things there. So at the very top in the center, the Peltier device, and again, I really just want to give a quick overview and brief of this to this group, and then you can go in and look deeper into the slides and read some of the detail. But it talks about the directional pull and directional movement of heat transfer to and from certain areas that you may require. Down below that on the left, in the center is that filter end cap, and you can see it starts up with the degradation and then moves towards the small picture on the bottom right, which in comparison to the top left, you can see there is no degradation to that filter end cap when we pull it off. And then, of course, we're expanding into items with our own brands of PPE, personal protection, mask. We have registered with FDA, with NIOSH, with CE. So we have both a disposable filter system that goes with the N95 Type 3M mask that is now enhanced with graphene technology. And then we also have a reusable, which is a lightweight, amazing mask. And all of this is featured on our website at 2dglobal.com. So there are several versions of two-dimensional materials and combinations of two-dimensional materials. Again, there's a link down at the bottom if you'd like to get the PDF of this and follow through with looking deeper into the information discussed. I wanted to pull out three specific areas I thought would be most important for this group. The first is the general description of graphene just by itself, and you see that up there. Secondly is the evolution now and the emergence of the synthetic graphene materials, the Procene and Procene Nanos. And I have a slide coming up which kind of illustrates the importance of that. But this is a unique material that is derived from biomass. So where graphene is really harvested from the specific 1 atom thick layers of graphite and then manipulated, the Procene type synthetic graphene is developed from the start through a biomass process, which, as you can probably understand, is significantly more available and readily available. The other unique function of that is you can specify the particle size and different characteristics of the graphene to match specific requirements, whether it's for electronics or composites or fluid or cementitious use, things of that nature. And then a unique product that's arisen recently, it's just been introduced in the last couple of years, is CoreTrax. If you're not familiar with CoreTrax, it's off the Quora type format, the polyamide base, and what that is, it's designed as a barrier material. When enhanced with CNT, with Procene, or with graphene, the CoreTrax then takes on a unique characteristic and is used in everything from household chemicals, wood preservative, industrial, adhesives, agriculture, automotives, things like that. And I believe that especially within your container businesses and different areas that may kind of branch off from that, the core tracks will be an emerging technology into the future. So may be worth keeping your eye on there and looking into greater detail. So this is kind of a cross-section shot of a graphene material. And again, at the top in the white, you can see, click on, and you can see the actual micron view of the process that was used in taking this shot. I don't want to focus on the background as much as the center shot, where you can see the peaks and valleys and the spikes. And when I mentioned earlier that you can manipulate the graphene, this is actually a procene nanoparticle that has been specified to have specific lengths of spikes, peaks, valleys, waves, and this was used in an electronic transmission coding that needed to hit a specific wavelength with specific resistance, some various characteristics I really don't want to go into because some of that is confidential. But it's unique to see when you dig down in how you can almost imagine fitting these pieces in together, locking them in, creating matrices, creating direct flow energy processes, and how that can dramatically change everything that we're doing. Remember, as you look at everything we do today, whether it's paint, coatings, composites, even steel and concrete, it's really all about the molecular structure and how that molecular structure interacts to create that bonded matrices. What holds that together? Is it a van der Waals principle? Is it mechanical? Is it chemical? Is it catalyzed? And so, you can see that from a mechanical standpoint, the graphene can interact with that. Now, in formulating most products, the graphene will not be a chemical reaction. So it won't necessarily create a chemical adjustment or change or manipulation that you can see. It's primarily mechanical. Now, what it will do is it will impact the formulation or the continuance of other chemicals that are creating those catalyzed reactions or that are reacting in certain ways. So we could spend days on how to maximize your benefit for your specific application and product, but this kind of gives you an idea of what that looks like. And then if you focus in on the background, you can see how it's not as clean, it's not as neat, and really that's a different type of particle. And the caption says that, do clients really know what they're using? Have they taken time to really understand the particle and the molecular structure and how that interacts and what they are actually purchasing in the product they're receiving? There are some very exciting areas that are now bleeding over into the energy spaces, and that's with the use of graphenes and CNTs for enhanced thermal conductivity and coating. What we have here is, again, two different links, and then I have the piping here that has a coating on it, and essentially you can watch the video if you'd like when this gets sent, again in the spirit of brevity and time. Just to give you an idea, on that bottom left, we have about a milliamp that's applied to that, and the coating goes from ambient 70-72 to approximately 150 degrees in about a minute or so. So that gives you an idea of how valuable that can be, especially when you're in areas that require heat tapes or maybe even the regulation of a specific temperature for transfer stations, things of that nature. But what we've learned is how to use this, right? How to use it, for what they call electrically resistive type of heat coating. So in our opinion, there are limitless opportunities for the technology. It can be a replacement for a number of things that will not degrade. It can be used in protection. It can be used in de-icing, thermal management, and a number of different areas. And we're also working to offer this in different types of material, both solvent and waterborne technologies. The large picture in the middle at the top that is colored is a picture of a wall, a concrete wall that was 3D printed using graphene technology, an incredibly lightweight wall, working with HUD, the Department of Housing and Urban Development, with Dr. Ben Carson and Jason Bourne and their staff, Christopher Bourne. I don't know why I was thinking of the movie, I guess, The Bourne Identity, right? So you can get a chuckle out of that. But Christopher Bourne and his technical staff, and we are now going into high impact areas, hurricane regions, things like that. We've worked with the ambassador at the Bahamas. We've worked with the ambassador in other island areas, Puerto Rico, places like that, and the Smart Cities Council, to now create the foundations and the outer structures for buildings that are now 3D printed over 10 stories tall. They're done very efficiently, they're done very quickly, they're done lightweight, and there are a number of characteristics, including mitigation of mold, prevention of water penetration, things like that, that really allow us to expand the safety aspect within building and construction. And that's starting to make its move here into the United States with companies like D.R. Horton, who now use that technology within their walls and their coating boards and things like that. So a number of different areas that this technology is starting to penetrate. So let's just take a minute to look at the basic properties of graphene. So you see there the tensile strength compared to steel, right? So it's significantly greater, and the Young's modulus in PSI, the million in PSI, significantly higher. It's the highest tensile strength of any material known to man at this point in time. The thermal conductivity, as you can see, as it compared to copper, is massively higher, incredibly higher. The electrical conductivity is greater, so both thermal and electrical. It has the highest electron mobility of any material, and I want to focus on that for a second. As we mentioned before, anything that you're looking at, paint, coatings, composites, any type of material, is looking at the mobility of electron movement to move in and out of structures to create certain type of matrices, right? Certain formation of a direction to create strength or flexibility or something of that nature. What graphene allows is the ability to manipulate that and create various levels of electron mobility in materials that can allow you to reach a specific target that you're looking for, which may be a combination of everything, right? Flexibility, verbosity, tensile strength, hardness, whatever that may be. It also has the fastest moving electrons of any material. So the electrons not only move more freely and they're more mobile, but they move significantly quicker. Capacitance, you can see there, and that kind of relates back to what we mentioned a moment ago in the heat resistive coating that we showed on the previous slide. It is the thinnest material, and it does absorb light. So there's a number of applications that we're working with there. You can imagine, for example, on solar panels, right? Graphene is becoming one of the highly spec'd materials to add into and create opportunities to absorb and retain light properties. So this is the rubber SBR tires and gasket seals. There's a video there that talks about the work that has been completed with graphene and the use of rubber and tires. This is a picture of that gasket that you saw, the degraded gasket. This is up close to show you the other end of it did not degrade at all. In fact, it had less than a 0.001 degradation, where the other was 97% degraded. And so we've been working diligently with different types of companies and materials, people like the filtration group, and in areas to enhance the technology related to the use of graphene in these areas. This is a project scope. Again, I'll get through this quickly. You can go in and click on the link and see the full test, but it's really gives you an idea of how graphene can be used to create that separation and that movement within bearings and applications that may need it through the use of graphene in crankcase oils, greases, different lubricants of that, and it goes into greater detail how that nano lubricant can reduce the coefficient of friction in a traditional lubricant in any laboratory tribological test. And Aline and I have had some discussions on this. We've actually conducted some co-presentations on the testing that's been conducted and the effectiveness and positive impact of graphene in these crankcase oils and different engine oils, greases, and things of that application that apply to the use in ball bearings. And high stress, high heat, high pressure, high temperature, high velocity type areas that obviously you work with on a daily basis. We also work with NASA. I'll just blow through this. I wanted to focus in because we provide the materials that help develop the sensoring and the biosensoring systems for the missions that are occurring. And we understand your need for environmental sensoring, for biological sensoring, for different types of feedback, and we participate in that area. So this is an area that may continue to bleed over and impact positively impact your industry. Another quick slide. Again, great video that shows you how this works, but this is the inflatable barrier control system. This goes back to that spill mitigation, flooding, things like that. This starts out as a very simple material bag. It can be burlap or a synthetic material. It's basically 8 to 12 pounds, 8 to 12 ounces. It has the material that we have inside of it, which is the super absorbent polymer, along with the graphene enhancement. And basically within a minute to 90 seconds, as soon as water starts to penetrate, it expands into the equivalent to a 25-pound sandbag. So if you've seen the Red Cross working, if you've seen some of the help out there, you see people with the sand and the bags and the shovels and the trucks and the craziness. You just pull these things off, you lay them down. The unique aspect here is as they start to swell, they also interlock. So unlike a cementitious material that is somewhat rigid and rough and hard, as this polymer develops and the water penetrates and it inflates, then it also it becomes interlocked with other bags that are around it. And then on the cleanup, it reduces back down to about a pound to a pound and a half, and it encapsulates and neutralizes hazardous materials. So now you have the ability to dispose of this in a very different fashion than you would if you had to pull down those cementitious bags, open those up, burn the bags, reclaim the sand or broken cementitious material that was in that. So it's extremely efficient. It's safe. It's very easy to use, and we believe as this makes its way into emergency response and hazardous material response, it will become the standard in the future. So the future of graphene, right? The future is we believe it's made up of graphene, right? So we've gotten past the hype and the tipping point into its actual use in industry applications. Tougher, stronger, lighter. So we have the technology for plastics, compounds, polymers. The durability, the water resistance, the OTR, right, the oxygen transition ratings can be manipulated through the use of graphene, and adjusted core tracks. The material that I mentioned has a lot to do with that, pulling that together. Electrical conductivity and thermal profiles, all while reducing thickness and most importantly reducing weight, and of course reducing your carbon footprint, because this is a carbon-based completely organic material. This just talks about the plastics in production and the responsibility of producers and the greenhouse gases. And of course, it's our kind of our charter as our materials to create durability, create all the unique characteristics you're looking for, while at the same time reducing your carbon footprint. So we ask that you all join us here at 2D Global in our mission to create a better, cleaner world for everyone. And I understand that the work at EPG is very focused on this. A number of the key charter members and the members that are leading this organization, their independent companies are all focused on this idea. So everything at 2D is about healing the earth, about reducing the carbon footprint, carbon negative manufacturing to create a better world. So our diverse offering of material and options believe that we can offer that unique, sustainable impact, positive impact, high performance differentiation from the competition. So to close, we just ask, where would you like to be? This is a kind of a fun slide. I'll leave it up for a moment. You can look back at kind of where the evolution of textiles and the railroad, and then of course automobiles moving into the computer age. And then, so where do we fit in nanotech, right? We're, take 1997 up to 2025, and we're kind of right in that space, really in its infancy. We're in the infancy of understanding it, of understanding the use of it, and most of all, understanding the full impact. But where can this go as AI emerges, different types of platforms emerge? Where will these types of materials then become present, and how would that presence now positively impact your industry? So again, I thank you for the time that you've spent with me today. I am humbled and honored that I've been given this slot. Aline and your gracious staff, thank you so much for all of the help in putting this together. This has been a wonderful 3 days for everyone who has participated. And if you have any questions, my email, my phone number, our website at www.2dglobal.com. Feel free to go in, send us an inquiry. We'd love to sit down and talk with you. Have a great day and be safe.